Good day. Today I will discuss the principles of a circle. So in principle 1, it stated that in a circle, the diameter divides two equal parts or two congruent semicircles. Like for example, this is a circle. So we all know that a diameter is a chord through a center of a circle. So like for example, this is a chord, a line segment AB, then the point C and D. So if line segment AB is a diameter of a circle, then arc ACB, so this is a symbol of an arc. So arc ACB is congruent to arc ADB. So again, in principle 1, in a circle, a diameter divides two equal parts or two congruent semicircles. So this is our semicircle. So it divides two equal parts. So this is 1 and 2. So it divides two equal parts. Arc ACB and arc ADB. Got it? So next is principle 2. So in principle 2, it stated that if a chord divides a circle into two equal parts, then it is a diameter. So for example, this is our chord. So line segment AC and line segment AB. So in a circle, line segment AC and line segment AB is our chord. So if a chord divides two equal parts, then it is a diameter. So in principle 2, so it converts the principle 1. So in principle 1, it stated that in a circle, the diameter divides two equal parts or two congruent semicircles. So it converts the principle 2. So next is principle 3. So in principle 3, it stated that a point is outside on or inside a circle according to whether its distance from the center is greater than, equal to, or smaller than the radius. So like for example, so this is our circle. So diameter AB, then this is our center, point D, point C. So if F is outside, so nasa outside sa circle, since line segment FO, so line segment FO, since line segment FO is greater than the radius. So if F is nasa sa outside, then greater than siya sa radius. So if ang E na pod, so if E is inside the circle, then it is small, since EO, line segment EO, is smaller than the radius. So smaller siya sa radius, so nasa sa inside the circle. Then A is on the center of a circle, since line segment AO is a radius. So this is a radius. So since line segment AO is a radius, then nasa sa center. So nasa sa center, or nasiya sa na-align na jud siya sa center sa circle. So muna siya principle 3. So now let's discuss about the principle 3. So in principle 3, it stated that radii of the same or congruent circles are congruent. So like for example, in the illustration, so line segment OA is congruent to line segment OC, since all radii of the circles are congruent. So line segment OA is congruent to line segment OC. So again, in the principle 3, it stated that radii of the same or congruent circles are congruent. So that is the principle 3. Next is principle 5. So in principle 5, it stated that the diameters of the same or congruent circles are congruent. So like for example, this is our circle, then A, point C, point B, and point P. Then this is our center. So the diameters of the same or congruent circles are congruent. So thus, if AB, a line segment AB is congruent to line segment CD, since the diameters of the same or congruent circles are congruent. So line segment AB, and line segment CD are congruent, rather. So that is a principle 5. So next is principle 6. So in principle 6, it stated that in a circle, if in the same or congruent central angles have congruent arcs. So na siya congruent arcs. So like for example, this is our circle, then this is our central angle. Line segment C, then B, So in the circle, in the same or congruent central angles have congruent arcs. So since congruent arcs man siya, so angle 1 is congruent to angle 2, then arc AC, so arc AC is congruent to arc CB. So congruent po siya sa arc CB. So since angle 1 and angle 2 are congruent, then ang arc AC is congruent po siya sa arc CB. So next is principle 7. So in principle 7, it converts the principle 6. So in principle 7, it stated that in the same or congruent circles, congruent arcs have congruent central angles. So like for example, if arc AC is congruent to arc CB, then angle 1 and angle 2 are also congruent. So this is a principle 7. So it converts the principle 6. So because in principle 6 it stated that in the same or congruent central angles, arcs have congruent arcs. So next is principle 8. So in principle 8, it stated that in the same or congruent circles, congruent chords have congruent arcs. So like for example, this is our circle, then the center is here, then A, B, C. So in the same or congruent chords in the same or congruent circles, congruent chords have congruent arcs. So if ang chord is congruent, then ang arcs pod is congruent. So example, line segment AB is congruent to line segment AC. So this is our chords. So if ang chords line segment AB is congruent to line segment AC, then ang arc AB is congruent po siya sa arc AC. So again, if ang chords is congruent, then ang arcs pod is congruent. So if line segment AB, so this is our chord. If line segment AB is congruent to line segment AC, then the arc which is the arc AB is congruent, then congruent siya sa arc AC. So, if ang chords is congruent, then an arcs is also congruent. Next is in principle 9. So, in principle 9, it's also stated that in the same or congruent circles, congruent arcs have congruent chords. So, ga-converse siya sa principle 8. So, if, for example, this is our circle again, then A, B, C. If the arcs is congruent, then the chords is also congruent. So, if arc AB is congruent to arc AC, then line segment AB is congruent to line segment AC. So, ga-converse siya sa principle 9. Sa principle 8, it stated that if the chords is congruent, then the arcs is also congruent. Then in principle 9, if the arcs is congruent, then the line segment or the chords is also congruent. So, ga-converse siya sa ang principle 9 and principle 8 are converse to each other, converses to each other. So, that is principle 9. So, next is principle 10. So, in principle 10, it stated that a diameter is perpendicular to a chord. Then, the chord bisects its arcs. So, for example, if line segment CD is perpendicular to line segment AB, then line segment CD bisects line segment AB, arc AB, and arc ACB. Again, in principle 10, a diameter is perpendicular to a chord. Then the chord bisects its arc. So, if line segment CD is perpendicular to line segment AB, then line segment CD bisects arc AB and arc ACB. So that is principle 10. Now let's move on to principle 11. So in principle 11, it stated that a perpendicular bisector of a chord passes through the center of a circle. So for example, if line segment PD is a perpendicular bisector of line segment AB, then line segment PD passes through the center of a circle. So that is the principle 11. So next is principle 12. So in principle 12, it stated that in the same or congruent circles, congruent chords are equally distant from the center of a circle. So this is our illustration of our principle 12. So if, for example, if line segment AB is congruent to line segment CD, then line segment OE is perpendicular to line segment AB. The next is if line segment OF is perpendicular to line segment CD. So next is if line segment OF is perpendicular to line segment CD, then line segment OE is congruent to line segment OF. So that is the principle 12. So next principle is principle 13. So in principle 13, it stated that in the same or congruent circles, chords that are equally distant from the center are congruent. So for example, if line segment AB, if line segment OE is perpendicular to line segment AB, then line segment OF is perpendicular to line segment CD. Then line segment AB is congruent to line segment CD. Again, in principle 13, it stated that in the same or congruent circles, chords that are equally distant from the center of a circle are congruent. So, if line segment OE is perpendicular to line segment OF, line segment AB rather, then line segment OF is perpendicular also to line segment CD. Then line segment AB, so line segment AB is congruent to line segment CD. So, congruent silang dua. So, that is the principle 13.